6, we're talking about square roots of perfect squares. How do we know if something is a perfect square? Do you remember from the past? How do we know if it's a perfect square? Berkeley, what do you think? Okay, all the sides are equal. What else do you think? Yeah? It could be an even number. Good. Now, we're going to find out the decimals and fractions can also be perfect squares. But let's take a look at what we have here. So, if we take a look at what's in this box, it says side lengths and areas of squares. So, whenever we find the area, we're counting everything inside. Now, the side length here is 5. So, if I take area is always length times width. So, if I go area of any square, I'm going to take length times width. But we know that our length and the width are the exact same size. So we can also say that area is equal to side squared for something that has an exact same size. So area of a square where the sides are the same, we get side squared. Can we use length times width? Yes. The numbers are just identical. So let's take a look and see what this gives us. We have area here. So that means it's our side squared. So length or side squared. Same thing. So our length is 5, I've got 5 squared, or length times width, 5 times 5. That's going to give me 25 little boxes in there. That gives me my 25 area. Okay? Area is how much space it takes up. Okay? That's what area means. Now let's go backwards. If I want to find out how long the side is, if I don't know that, and if let's say I didn't have an object to look at and count squares, if I didn't have something to look at, what would I do? I would use the reverse inverse operations. Okay, so since we're using opposite operations, I know that area equals side squared or length times width. Well, what is the opposite of a squared sign? What do you think? What's this thing over here called? Right, that's called a square root sign. Okay, so we're going to use the square root sign. So whenever I want to do the opposite of squared, I square root. So we would say that square root and squared are opposites. Okay, those are opposites. Okay, is what we're finding. Okay, so write that down please. Square roots and squaring. Okay, so squaring.
So what does that mean?
Okay, so square roots and squaring are opposites. Okay? So they are opposites. So when we take a look, what have they done to find the side length? They've taken the square root of the area. And we did that again. Okay. We need to take the square root of area. So if I take square root 25, over here I got an answer of 25. But if I take the square root of that, I'm going to get my 5. And that's how I know that it's 5 by 5 by 5 by 5. All the sides are the exact same. Okay? Let's continue with the next part. So you can see a diagram here. Let's make this a little bigger and see what we can see here. Oh, let's go here. Make it a little bigger for you. So right now I've got a diagram. On this side it says 7. And that means if it's a square, they're all going to be 7. 7 times 7. So here's my square model. Well, how do I find area? It's length squared or side squared. So what's 7 times 7, everybody? 49. Good. It's 49. Now, we're working backwards. If I have the 49 and I want to know the side length, I take the square root of that number. Okay? And that's going to give me 7. Okay? I want you to practice on B, C, and D. Push pause, push play when you're ready.
Yes.
All right, let's see what you got for B. So, we know that our side length is 4. So, area is 4 squared.
Yes.
4 times 4, which is going to give me 16. So, I should have 16 little squares in there. So, it says the area is 16 square units. Okay? Now, we're going to work backwards. We're going to square root our area, and that's going to give us our side length. Okay? So the square root of 16 gives me 4. And that's how I know that it's 4 units long. Okay, 4 squares long. And the side length is 4. Okay, now we're going to take a look at letter C. We have 8 for our side length. So our area is going to be side squared. That happens every time. Area is side squared, so it's going to be 8 squared. So we get 8 squared is
64.
64. So our area is 64. Now we're going to square root our area.
64.
Root 64 gives us how big?
8.
8. Good. So our side length is 8. It's working backwards. Enough, please. All the repeating needs to stop, please. 11 is our side length. So our area is going to be 11 squared, which is 121. So our area is 121 square units. Let's take a look now, work backwards. We go square root of our area, 121 gives us our side, so we get 11 is our side length's 11. So what is a perfect square? Let's figure it out, guys. So first of all, we know there's a couple different things that have to happen. The first thing that we know is that it's going to have that it is a number that has two identical, okay, that's the important part, they're two identical factors. Okay, and what's a factor? Numbers that multiply together. Okay, so it's two identical factors it has to have. Okay, that's what a perfect square is. How do you find it? How do you find perfect squares? Okay, how do you find a perfect square? Or should I say, how do you find perfect square factors? How do you find perfect square factors? This is a strategy we use. All right. How do we do it? We square root our area. Okay? You square root the area. That's going to give you the perfect square factors. Okay, that gives us our perfect square factors. And if we square root area, we also know that it gives us our side length. Okay, so our side length is the perfect square factor that's being used more than once to find our perfect square. So here's a chart about all of our perfect squares. We're going to fill the chart in. Let's see how many you guys know. Go through and use your calculators and fill out the rest of our chart here. So let's just follow the pattern first of all to make sure you know what you're doing. So we've got 1 squared is equal to 1 times 1, so length times width, to give us our area 1. Okay? Square root is we take the root of our area, and that gives us our side length of 1. Okay? So I want you to do all the rest of them from number 3 all the way to 12. I'll give you a couple minutes. Push play when you're ready. Okay, let's take a look and see what you got. So, perfect squares. We have 3 squared, which means 3 times 3 to give us 9. Well, we know the square root of 9 gives us 3. Good. 4 times 4, 16. Root 16 is 4. 5 times 5 gives us 25. Root 25 gives us 5. 6 times 6 gives us 36. So the square root 36 working backwards equals 6. Okay, on the other side, same way. 7 times 7 is 49. So the square root of 49 gives us the side 7. 8 times 8 gives us 64. So the square root of 64 has to be an 8. 9 times 9 is 81. Square root 81 is 9. 10 times 10 is 100. Square root 100 is 10. 11 times 11?
21.
121. 121, yep. So square root 121 gives us our 11. Our last one, 12 times 12 gives us
144.
144. So now we have root 144 to give us our 12. Good work. Let's see what happens if we have a picture. So now it says, can a fraction or decimal be a perfect square? The answer is yes, it can. Okay. So how much is shaded? So let's take a look. If this is a 10 by 10 shaded, how many squares are shaded? Well, I've got 9 out of 10 squares shaded this way. I'm going to shade it this way. 9 out of 10. Good. So what is its area? Well, area is going to be 9 out of 10 times 9 out of 10. Okay? What does that give us? Who knows how to do that? Well, what we do when we're multiplying fractions, we multiply top numbers and then we multiply bottom numbers. So that's going to give us 81 over 100. So there's 81 squares shaded there out of 100 total squares. Okay, what's that? That will be the area, yeah. So this is our area. Okay, let's move it up. So it says, write the area as a product. Well, I know that this is written as a product, 9 over 10 times 9 over 10. But since it's the same number, can I write that a different way? How can I do that? 9 over 10. Can I write that a different way? Absolutely perfect. So this is going to be 9 over 10, and I have 2 of them, so square it. Okay, that's area as a product. Now, you can write it this way, the way the green one is, or you can write it the way I did the red one there, just with repeated multiplication, because that 2 tells us we have 2 of them. Okay? All right, so there's our area. Now, can we square root those to find our side? Absolutely. But we can't take the square root of the whole fraction. How do we square root fractions? We take top separate from bottom. So what I'm going to do first is I'm going to do square root 81 on top of square root 100. That's how I square root a fraction. So I find out then, square root 81 gives me 9. And the square root of 100 gives me 10. And what do you both notice about 9 over 10? It's the same as my side length, which it should be, okay? All right, here's another one. Same thing going on here. Now, this one's kind of like a decimal. This one's got 9 out of 10. So you have to take a look. It says that it's 1 unit. It says that all of these squares together make a 1. So it's kind of like a number line. So what you want to do is count, since that's 10 squares makes 1 full unit, I've got 9 out of 10 squares that are shaded. Same thing down here, 9 out of 10 squares shaded. So it looks like the exact same thing as my last question. Now, is it possible? Yes. Let's change that to a decimal. We're going to use decimals now. What's 9 divided by 10 as a decimal? 0.9. 0.9. So what do you think each one of these boxes is? 0.1. They're counting by 0.1. So if I have 0.1, 0.1, 0.1, I add them all together, all the 0.1s. If you have 10 0.1s, take 10 times 0.1. What would you get? 1. Good. That adds up to my whole side here. So you've got 0.9 and 0.9. So let's find our area then. So area as a product is going to be 0.9 squared. Or I can write it as repeated multiplication. So I can go 0.9 times 0.9. Now you can write a little dot in the middle, but I usually put them in brackets because I'm using decimals. And I don't want to get my decimal sign mixed up with my multiplying dot. So that's why I'm using brackets. Does that make sense?
Yep.
Yes.
Otherwise, usually we put a big fat dot in the middle and we multiply, correct? All right. So now let's multiply that out. What do you guys get for an answer as a decimal? That's right, 0.81. So we're going to get 0.81. And now when we looked at our other one, we got 81 over how many? Over 100. Okay, and that's exactly what 0.81 is as a fraction. Okay, so decimals and fractions can both be used as perfect squares. Now, can we square root this? Absolutely. Let's go square root of our 0.81, and what should we get? We should get our side, right? We should get our side. Check it and make sure. Practice, use those fingers and use your calculators. That's right. Yes, you should get 0.9, which is our side. Okay, so we're square rooting the area to get our side. Okay? All right. Let's fill out this box now. So since we've got a chart here. Oh, sorry, I'll go back. What were you waiting about here, dear? Okay, let's move on to the chart. Area as a product. So this wants us to write it as a product, meaning length times width or side squared. Okay? So if this is my area, how do you find the side length? Well, I got to find the side length first. So I know that the side length is going to be the root of the area. So that's going to be root 49, which is how big? 7. Excellent. So if I want to write it as a product, how do I write that then?
7 squared.
Good. 7 squared, or 7 times 7. Okay? Let's take a look at the next one. It's a fraction again. So since I have a fraction, how do I deal with the fractions? What am I going to do? Can I put it all into the square root sign to begin with?
No.
No. What do I got to do? Separately. Good. Top separate, bottom separate. So root 49 divided by root 100. Oopsie, that goes over on the right. This goes over here. There we go. That goes in there. So what's that going to give me for a side length when I solve that? How big is the root of 49? 7 we found. Good. What's the root of 100? 10. Good. So now my area can be 7 over 10 times 7 over 10. Or if it's a fraction, it has to go in brackets. So we're going to go 7 over 10 squared. Okay, so you write it with the squared sign. 64. So we're going to go root 64 to get our side, which gives us 8. So over here, I'm going to have 8 squared, or 8 times 8. Okay, you fill in the rest of the chart. Push pause and push play when you're ready. Okay, we're going to take this up now. We've got a couple minutes to work on it. So we're going to take the square root of 64 and the square root of 100 to give us 8 over 10. So in here, for my factors, I'm going to have 8 over 10 squared, or 8 over 10 times 8 over 10. Now they're fractions, so they should be in brackets. Okay? Over here, I'm going to have the square root of 121, which gives me 11. So here I'm going to have 11 squared, or 11 times 11. The bottom one, or second last one, I'm going to have root 121 on top of square root 100, which is going to give me 11 over 10. We're going to notice that our top number is bigger than our bottom number. Is that okay? Yeah, that's okay. So this is going to give me 11 over 10 squared, or 11 over 10 times 11 over 10, whichever way you like to do it. Okay, same thing on the very bottom one. We're going to square root both numbers. So we're going to get square root 16 on top of square root 25, which gives me 4 on top of 5. So over here, I'm going to get 4 over 5 squared, or 4 over 5 times 4 over 5. Okay, let's move on to some fractions. Okay, now let's take a look at fractions. They say it is in simplest form of a perfect square if it can be written as the answer of 2 identical factors. So, is my perfect square an answer of perfect square? Absolutely. 1 times 1 will give me 1. 4 times 4 gives me 16. So, I take the square root of 1 over 16, which gives me 1 over 4. Because the square root of 1 is 1, square root of 16 is 4. So then we say that yes, 1 over 16 is a perfect square. How come? Because the answer has 2 identical factors that made the answer. Okay? So 2 identical numbers makes the answer. Same thing here. 0.25. Everybody put 0.25 in your calculator. And then I want you to take the square root of that. And what do you get? 0.5. Good. So yes, it's a perfect square because you get 0.5 times 0.5. Okay? So it's 2 of the identical numbers multiplied to give us our answer. Okay? So decimals and fractions can be perfect squares. Okay. Let's take a look at 1/3 times 1/3. What does 1/3 times 1/3 give us, do you think? 1 over 9. 3 times 3 is 9. Okay, so we're going to say the square root of 1 over 9 then is 1/3, because that's what I use to multiply by itself to get my 1 over 9. So then it says, yes, 1 over 9 is a perfect square, because both the top and the bottom can be square rooted. But let's check this number. Check this one out. Let's say I go example root 24 over root 25. Let's see what that gives us. Everybody try to go square root 24 and see what you get. What do you get on the calculator? Okay, what do you get, Berkeley? For square root 24?
No.
Just square root 24.
4.8989.
Good. 4.89, blah, blah, blah. It runs on forever. It filled your whole calculator screen, didn't it? Okay.
It's a run-on.
If a number fills your whole calculator screen, it's a run-on decimal. Or it could be a repeating decimal. Okay? So, run-on decimals are not perfect squares. So, but if I check my bottom, root 25 is a 5. So how do you know if this is a perfect square or not? It can only be a perfect square if the top and the bottom give you answers where the decimal ends. Does the decimal end on the top? No, it doesn't. It does on the bottom, it ends, but on the top it does not. So this one we would say is not a perfect square. Okay, not a perfect square. Because it doesn't work both top and bottom. Both numbers have to work for it to be considered a perfect square. Okay? Let's move on. So it says when a decimal can be written as a fraction that is a perfect square, then the decimal is a perfect square. Okay? The square root is a terminating, that means it ends, a decimal that ends, or repeats. Repeating decimals can also be perfect squares. So we checked 0.25, is it a perfect square?
Yeah.
Yes, because when we took 0.25, when we square rooted it, we got 0.5. Now, if I wanted to put 25 or 0.25 as a fraction, how would I put 0.25 as a fraction? Do you remember? You're exactly right. What would it be? Right, so going to 25 over 100. Now, I want to go in simplest form. Simplest form means you break it down as low as it goes. They have to divide by the same numbers. Well, whenever they end in a 5 or a 0, you try and divide by 5s. Can I divide both of them by 5s?
Yes.
Yep. So if I do, I'm going to get 5 over 20. Does that go even lower?
Yes.
Yes, it divides by 5 again. What do I get? 1 over 4. So it gives me 1 over 4. Okay? Oh, sir, this one was wrong. Pardon me. It gives us 0.25 gives us 0.9. No, that was right. There we go. That was right. Okay, so it says, can the fraction be written as a product of two equal factors? Well, that's 1 over 4. That is my 25 over 100 gives me 1 over 4. Okay? That's what it's telling me, 1 over 4. So, what's 1 over 4? What do you get? Yeah. Well, this is area though. This is still my area. So that means I've got to square root the top and square root the bottom. What do I get? 1 over 2. So that means my area is 1 over 2 squared. Well, what's 1 over 2? It's 0.5. And what do we get when we square root the decimals? 0.5. So we still get this as 0.5. Okay, so 0.5 is the side. Now I want you to try this one. 0.4. Take the square root of 0.4 and see what you get. Is it a perfect square? Everybody try that, please. Try 0.4 and see what you get. Okay, so this is not a perfect square. So we would say it equals a run-on decimal. So no, not a perfect square. Okay, it's not a perfect square. We're going to try these ones. Let's go to the next page, or the bottom of your page. The bottom of your page has a few things for us to look at. We want to find the number whose square root is that answer. So the square root is this number, which means this is the side. Okay, these are the sides. If I want to find the perfect square, I need to do what to that number to find the area? I got to square it. So I need to take 12 squared, that's going to give me my area. So what would I get for 12 squares? 144, great. I want you to do the rest of the questions, and I'll check you in a moment. Okay, so you should have got 9 times 9, or 9 squared. That gives us 81, great. See, 1.8 squared? 3.24, good. What is 2.3 squared? 5.29, good. Fractions, square top and bottom separate, what do you get? 9 over 64 and 1 over 25. Excellent. All right, now look at this one. Is 8 over 18 a perfect square? Well, not the way it's written. Not now. How come? You must reduce first. Okay, we must reduce first always before we can tell if it's perfect square or not. So I can divide both numbers by what? 2. Okay, they both divide by 2. 18 does not divide by 4. So if we take 8 and divide by 2, and 18 divided by 2, I'm going to get 4 over 9. Is that a perfect square? Yes, because both the top and bottom both are. We can check because we have to take the square root of them to check. So root of 4 is 2. Root of 9 is 3. So 2 over 3, perfect square, absolutely. They gave me an answer that did not give me a run-on decimal as a top number. I didn't get a run-on decimal as a bottom number, and my answer is a repeating decimal. So yes, it's a perfect square. So, can the fraction be written as a product of 2 equal factors? Then yes, it's a perfect square. Like I said though, the top number and the bottom number both have to work. So this one's in simplest form. Let's check top and bottom and see if it works. So root 16, how big is it? 4. What's the root of 5? No, it's a run-on decimal.
Yeah.
So, if one of them is a run-on decimal but not a repeating decimal, it is not a perfect square. So we see this is a run-on decimal. One of our numbers gives us a run-on decimal. So this one is no, not a perfect square. Okay, because both numbers did not work. Okay, the top one did, but the bottom one did not. So no, it's not a perfect square. Let's look at the last one here, example 3. It's saying, is each decimal a perfect square? We have 2 different ones to check. So if you take the very first one, first of all, see if you can write it as a fraction in simplest form. So this gives me 6 and 25 over 100. Then you're going to reduce the 25 over 100, so that's going to give you 6 and 1 over 4. Now you're going to change it to an improper fraction. So you're going to times the side, and you're going to add the top to give me 24 plus 1 is 25 over 4. If you look at 25 over 4, my top number can be a perfect square, and so is my bottom number. That's going to give me 5 over 2. So yes, both numbers work out. They are perfect squares. Now it says, can the fraction be written as a product of 2 equal factors? Yes, so you've got 5 over 2 times 5 over 2. That's going to give us 25 over 4, which was our fraction that we converted to. Now we could have done that really quick in our calculator and just taken the square root of 6.25. It would have given us 2.5. And if we check, 5 over 2 is 2.5. So this gives us 2.5 as an answer for a perfect square. And what is 5 over 2? It's also 2.5. So you can do it either way. You can just square root the decimal, or you can change them to fraction form. Either is correct. So let's just take the next question. If I go square root 0.628, we will see that no, this question is not a perfect square. It's not a perfect square because the decimal I get is a run-on decimal. I get 0.7874007874, blah, 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 it runs on forever. And it fills our entire calculator screen. When that happens and there's no pattern, then yes, it is definitely, well, this one actually gives us a run-on, the run-on decimal though actually is a repeating decimal. Let's check this out as a fraction. So when I do check my fractions, so this would give me 62 over 100. 62 over 100 reduces, but it reduces to 31 over 50. And neither of those can be reduced as a perfect square. They will each give me run-on decimals. So no, this is not a perfect square. This concludes lesson 6 on perfect square roots.